Recording in progress.
This video is going to cover the homework workthrough that you guys should have done on Friday. Going through section 5.6, solving by completing the square. So the first 6 are simply finding that third term in the perfect square trinomial. And so we're finding out what number would give us a perfect square binomial and eliminate that middle term. Okay, so all we have to do is, we look at what number plus itself equals 12, and we know that 6 plus 6 equals 12, and therefore we find, and it's positive, so we know it's positive, so 6 times 6 gives us 36, so that last term is 36, and then our squared binomial would be x plus 6 squared. All right, the next one we have a negative 16. So we know that negative 8 plus negative 8 would give us a negative 16. So in this case, our third term, well, in the trinomial is going to be positive. But when we have the squared binomial, make sure that you include it as a negative. So negative 8 times negative 8 gives us a positive 64. So this number is 64, and then our squared binomial is x minus 8 squared. And we pretty much go through the rest of these just like that. I know that negative 5, this is where we need to actually use our formula. So we know that b equals negative 5. All right, so once you know that b is negative 5, and then we also know that to find our c term, then we have b over 2, or b times 1/2 squared. So this equals negative 5 over 2 squared. And negative 5 times negative 5 is a 25. Make sure that doesn't end up being negative. And then 2 squared is 4. And so we have our third term, it's 25 over 4. And this inside what's being squared, the negative 5 over 2, that's the second term in our squared binomial. So we have x, and it's minus because that 5 is negative, x minus 5/2 squared. All right, so for this one, again, our coefficient here, or b, is negative, coefficient of the middle term, is -1. So if b equals -1, then our formula b times 1/2, or b divided by 2 squared, is going to be -1 over 2 squared. And so we have 1/4. So 1/4 becomes our third term in the perfect square trinomial. And then I'm just going to put it underneath here, I'm running out of room. This is that middle term. So this is x minus 1/2 squared is our squared binomial. All right, so for number 5, we have a fraction as our b term. So b equals a positive 5/4. Leave it as a fraction, don't turn it into a mixed number, it just makes things more confusing. And so in this case, give me just a second. All right, I know what I did. I repeated what I saw for number 6. This should be, I think it's 2/3. Yeah, it's 2/3 in. So b is 2/3. Therefore, this is 1/2 times 2/3 squared. We have to simplify inside the parentheses first. So when we do the math, we end up with 2 over 6 squared. Actually, I'm going to do that over here. If I have 1/2 times 2/3, those cancel out and I end up with 1/3. So this becomes 1/3 squared. And that makes my, so this is my, in the term inside of my squared binomial. And this is 1 times 1 is 1, and 3 times 3 is 9. So the last term here is 1/9, and my squared binomial is x, not the b term, I'm sorry, the 1/3, x plus 1/3 squared. Except it's in because they changed it up on me. I do that for like everyone. Oh well, it's early. All right, so now for 6, we have another example of this. So I have b is equal to 5/4. That simplifies, so we have to multiply it times 1/2. All right, so 1/2 times 5/4 squared. I'm gonna come over here and simplify that. So that's 1/2 times 5/4. Excuse me, gives me 5/8. Can't do anything else with that. So this becomes 5 squared over 8 squared. Go down here. And so that's 25/64. So this here is my third term in the perfect square trinomial. So it's 25/64. And then the 5/8, excuse me, that's going to be the term that goes inside of my squared binomial. So this is x plus 5/8 squared. And that's it. Okay, so moving on to number 7. The rest of these we're actually solving. So what we have to do is, again, we have to turn the binomial, well, it's sort of a binomial, the x squared minus 4x, the binomial, into a perfect square trinomial. And in order to do this, I need to look at what numbers. So I know that -2 plus -2 gives me -4. So -2 times -2 is 4. So I'm going to add, so this is x squared, let's see here, x squared minus 4x plus 4. It's going to equal 45. But if I do it, if I add 4 to one side, I have to add 4 to the other side. So I end up with, this one becomes x minus 2 squared equals 49. So our next step is we take that, let me move this. We take that x minus 2 squared, and we apply the square root property, square root of 49. So we end up with x minus 2 equals plus or minus 7. And then we isolate x. We add 2 to both sides, but we can't add that 2 to the plus or minus 7. So we write it as x equals 2 plus or minus 7. Now we can solve. So we have x equals 2 plus 7. That's a 9. And we have x equals 2 minus 7, which gives us a -5. Those are our 2 answers. And moving on to the next one here. X squared plus 2x. So I know that 1 plus 1 is 2, and then 1 times 1 is just 1. Try to keep the same. And so if I'm adding 1 to make that a perfect square trinomial, then I have to turn around and add a 1 to the other side as well. And so this becomes x plus 1 squared. It's 4. So another nice option, both sides are perfect squares. So I have the square root of x plus 1 squared equals the square root of 4. That those cancel each other out. We end up with x plus 1 equals plus or minus 2. 2 times 2 is 4. All right. Last step, we subtract, well, sort of last step, we subtract 1 from both sides. We get x equals -1 plus or minus 2. So now we can solve. X equals -1 plus 2 gives us a 1, and x equals -1 minus 2, which gives us a -3. And those are our two answers, two solutions for x. All right, so for the next one, we are just going to move the plus 8m and then turn it into a perfect square trinomial. So I just add 8m to both sides. I get m squared plus 8m equals -7. And I know that 4 plus 4 equals 8. So I have m squared plus 8m plus some number equals -7 plus that number. 4 plus 4 is 8. 4 times 4 is 16. So I'm adding 16 to both sides. And so this becomes m plus 4 squared equals 16 plus -7 is 9. And now we can solve. So the square root of m plus 4 squared equals the square root of 9. Cancel out. This becomes m plus 4 equals plus or minus 3. Subtract 4 from both sides. We have m equals -4 plus or minus 3. So now let's go ahead and solve. M equals -4 plus 3, which gives us a -1. Equals -4 minus 3, which gives us a -7. And those are our two solutions. All right, moving on to number 14. So for number 14, we've got to move quite a few things around. So we need to get this constant here. 60 is not a perfect square. So I'm going to move it to the right side. And that 4n I need over with my n squared. So I'm going to move that to the left. I end up with n squared minus 4n equals 60. All right. So now -4, excuse me, n squared minus 4n, that's -2, or plus -2. So x, so that means -2 times -2 gives me 4. So I'm adding 4 to both sides, and I end up with n negative minus 2 squared equals 64. So n minus 2 squared, and then take the square root of both. Square root of 64. Let's cancel, and we get n minus 2 equals 8 plus or minus. Add 2 to both sides. And your final answer is n equals 2 plus or minus 8. And now we solve. So n equals 2 plus 8, so that's 10. And n equals 2 minus 8, which gives us a -6. All right, 15 continues the steps, except I believe now we're going to start incorporating that imaginary number, the I. So we have to move this 5 over. That is not part of a perfect square, so we end up with x squared plus 4x. Excuse me, that's negative. Plus that third term equals -5 plus that number. And -4, so we just did that, I think. -4 is -2 plus -2, so Negative 2 times negative 2 gives us positive 4. So we're adding 4 to both sides. So on this side, we end up with x minus 2 squared. And on this side, we have a negative 1. All right, yep. So now we're working with negative numbers inside a square root. So we have square root of x minus 2 squared equals square root of negative 1. So we know by definition, square root of negative 1 is I, but it's going to have a plus or minus in front of it. So we can't forget that. So this is plus or minus I. We add 2 to both sides, change colors. And that constant goes first, so 2 plus or minus I. That's as far as we can go. We can't solve it into real numbers because we have that imaginary number. All right, 16, another one. So we're going to take away the 10 from both sides. We end up with x squared plus 4x plus some number equals negative 10 plus that number. So again, positive 4 is 2 plus 2, so 2 times 2 is also 4. So we're going to add a 4 to both sides. And for this side, we end up with x plus 2 squared equals negative 10 plus 4, which is negative 6. So now let's solve using the square root property. So square root of x plus 2 squared equals the square root of negative 6. These cancel. I end up with x plus 2. 6 is just 2 times 3. There's no perfect square that's a factor of 6. All I'm doing is pulling out the I. And so we have plus or minus I square root 6. So the last step is I'm going to subtract the 2 from both sides. And my final answer is x minus 2 plus or minus I square root 6. That is as simple as we can get it. Okay, so for number 17, they've given us the complete perfect square trinomial. We know that 9 is 3 times 3 plus or minus, but negative 6 is negative 3 plus negative 3. So we know that inside of our squared binomial, we're going to have an x minus 3 squared. And we don't have to add anything to either side, so it equals 25. And now we just square it, so, or find the square root of both sides. So this is x minus 3 squared equals 25 squared. So these cancel, becomes x minus 3. 25 is a perfect square, and so this is plus or minus 5. Last step is I'm going to add 3 to both sides. I get x equals 3 plus or minus 5. This I can actually solve. We don't have any imaginary number. So to solve that, we have x equals 3 plus 5, which is 8. And we also have 3 minus 5, which is negative 2. Done. All right, 18 is the same thing. We've got 6 times 6 equals 36. 6 plus 6 equals 12. So we know we've got a perfect square trinomial. So on this side, we have x plus 6 squared equals 50. All right, so let's go ahead and use our square root property to solve. We have x plus 6 squared equals the square root of 50. Cancel out. We have x plus 6 equals, let's see, 50 is 25 times 2. So I know that the 25 can become a 5. So this is plus or minus 5 square root 2. 2 has to stay in there. All right, and then last step, we add 6 to both sides, or excuse me, subtract 6 from both sides. We end up with x equals negative 6 plus or minus 5 square root 2. And I am pretty sure, yep, we just leave it at that. Because you cannot combine the negative 6 and the 5, because the 5 order of operation tells us the 5 has to be multiplied by the square root of 2 first before you add it to the negative 6. And -1 times square root of 2 is very different than -6 plus 5 square root of 2. So then you would leave it. This is it. Okay. Let's see here. So for 19, we have that variable in front of, or not variables, excuse me. We have a coefficient for our squared term, the y squared. So we have a different first step. We have to make sure that we isolate the y squared. So for step 1, we have 2y squared plus 7y equals 4. We have to divide all the terms by 2. And this becomes y squared plus 7 halves y equals 2. So once we have that, we can then figure out what our last term is going to be. So for this one, I take the 7 halves, and this is our b over 2 squared. So that's 1/2 times 7/4 squared, and that gives me, oh, wait a minute, it's 7. I'm getting ahead of myself. It's the 7 over 7 halves. So this becomes 7/4 squared. That is super ugly. All right. So the last step we do is, let me go ahead and turn this into, so 7 squared is 49, 4 squared is 16. So I'm gonna have to take my 2, this guy right here. So 2 plus 49 over 16. I'll just change my denominator 16. 16 times 2 is 32. 32 over 16 is 49 over 16. 10, 11, carry the 1, 4, 5. So 81 over 16. All right, so that gives me the solution to the squared binomial. And let's see, let me go ahead and write all this in. So if I change that to y squared plus 7 squared y plus some number equals 4, no, not 4, 2, plus that number. And that number we found out was 40, let's see, 49 over 16. All right, that was step 2. And then step 3 found the constant that goes in our equation. So when we write that, we have our perfect square binomial, or our squared binomial. So this is y plus 7 over 4. This guy right here. Squared equals, and I just calculated the 81 over 16. All right, so now we have to solve. So we have the square root of y plus 7/4 squared equals, and I'm going to go ahead and I'll leave it, 81 over 16. All right, so these cancel out, and I end up with y plus 7/4 over the square root of 81 over the square root of 16. And I know that that is 9 over 4. So that equals plus or minus 9/4. All right. Now we subtract the 7/4 from both sides. Y equals negative 7/4 plus or minus 9/4. Now we have a common denominator, so that helps us out a little bit. So y equals negative 7/4 plus 9/4, which gives us 2/4, which is 1/2. And y equals negative 7/4 minus 9/4, which is negative 16/4, which gives me -4. Those are my two solutions. All right, let's do it again. We've got that variable in front of the square term, so we've got to get rid of it. So this is 3z squared minus 14z equals 5. Divide everything by 3. We end up with z squared minus 14/3z, 14/3, equals 5/3. I know, ugly. All right, I'm gonna go ahead and move that over here so I don't forget what's what. So this is z squared. Z squared minus 14z, excuse me, 14 3z, and then I'm going to add some number to it, and this is 5/3 plus that same number. All right, so let's go ahead and figure out what that number is. So we have step 2. So this is the, again, this is the b/2 squared. This is what I'm using. B divided by 2, because we're working fractions, I'm just going to change that 2 to multiplying times 1/2. So this is 1/2 times b, which is negative 14/3 squared. And so that equals negative 14/6 squared. And I'm actually going to keep that like it is. Negative 14/6 squared. This is negative 14/6 squared. Because in my squared binomial, that negative 14 plus 6 is the second term. So I can go ahead and write that, and then I'll solve the other side first. So this is z, and it's negative, so we subtract z minus 14/6 squared is my squared binomial. Let me go ahead and do step 3 here, and I'm going to do the 5/3 plus squared. Okay, so 14 squared is 196. And then 6 squared is 36. So I know that I have to multiply that 3 times 12. So I'm going to rewrite that. So 5 times 12 is 60. 3 times 12 is 36. That gives me a common denominator, 196/36. So 19 plus 6 is 25. 256/36. At least they're nice enough to give us perfect squares. All right, so our final equation is z minus 14/6 squared equals 256/36. Now, because in the end, we're going to get a common denominator if we just leave that 14/6 like it is, instead of reducing it into 7/3, I'm just going to leave it. So now that we have our final equation, we can use our square root property and solve. So this is the square root of z minus 14/6 squared. Oh, my internet's starting to go wonky. Equals, and I'm going to go ahead and just square both of these separately. 256, square root of 256 over the square root of 36. And that cancels. This becomes z minus 14/6 equals square root of 256 is 16. So plus or minus 16/6. My last step, I'm going to add that 14/6 to both sides. And I get my final solution, z equals 14/6 plus or minus 16/6. So now let's solve for z. Z equals 14/6 plus 16/6. So 6 plus 4, carry my 1, 30. So this gives me a positive 5. And then z equals 14/6 minus 16/6. 14 minus 16 is -2. Divide both by 2, and I have -1/3. So there's my solution, 5 and -1/3. Almost done. Okay, 21, we have 3x squared plus 6x minus 7 equals 0. There is no combination it's going to give us, first off, anything squared is not going to give us a negative. So this is one of those examples, and this would not be easy to find our any sort of solution. So we have to move this 7 over. We end up with 3x squared plus 6x equals 7. Now again, we've got a term with our x with our squared, or excuse me, we've got a coefficient to our squared term. Look, I'll get it out eventually. So let's get rid of that. So again, step 1, 3x squared plus 6x equals 7, and we've got to get rid of that 3. So we divide all of these by 3, and we end up with x squared plus 2x equals 7/3. All right, so just a second.
Recording in progress.
All right, so we have x squared plus 2x plus some number equals 7/3 plus that number. And I'll just make it the color. So I know that 1 plus 1 equals 2, and 1 times 1 is 1. So here's my perfect square trinomial, x squared plus 2x plus 1. And so then I have to add a 1 over here as well. So on this side, I end up with x plus 1 squared. And so that 1 is equal to 3/3 with a common denominator. So that gives me 10/3. All right. Okay, I did this when I worked it out. I'm just going to show you where that 1 came from. If we used our formula, b/2 squared, b is 2, this guy right here. So this is 2/2 squared, and 2/2 is 1, and 1 squared is just 1. So that's where I got the 1, even though it's already easy to figure out. Just an example of using the formula. Okay, so let's go ahead and solve this. So square root of x plus 1 squared equals the square root of 10 over the square root of 3. So those cancel out. I know that this side is going to be x plus 1. Let's go ahead and simplify this. So this is square root of 10 over square root of 3. I've got to multiply it times 1 in the form of square root of 3 over square root of 3 to cancel out these guys. And so this becomes the square root of 30/3. Now there's no perfect square that goes into 30, so we're leaving it like that. Just have to remember it is plus or minus. So plus or minus square root of 30/3. And then I subtract the 1 from both sides. And our final solution is x equals -1 plus or minus square root of 30/3. And that's it. I can't do any more. Okay, so for number 29, x squared plus 3x, and we have a negative on the other side. So we're going to end up with some sort of imaginary number. First, let me go ahead and find my third term in the perfect square trinomial. So I know this is going to be x squared plus 3x plus some number equals -3 plus that number. All right, so my b equals 3. So since it's a whole number, I'm just going to put it over 2. So this is 3 halves squared. Just going to leave it like that for now. So I know that that goes in my perfect square, or my squared binomial. So 3 over 2 squared. All right, so this guy is x plus 3 halves squared. And that equals, let's see here, -3. That as a fraction. 3 squared is 9, 2 squared is 4. All right, so if I need to change this fraction, I got to multiply both of these by 4. So that gives me -12 over 4 plus 9 over 4. So -3/4. That goes right there. All right, so now we've got to solve for x. Square root of x plus 3 halves squared equals the square root of -3 over 4. Actually, let me go ahead and square root of -3 over the square root of 4. So I know the square root of 4 is going to give me a 2 in the denominator, which will be very nice. Okay, let's go ahead and do that. -3 over 4 means I have I square root of 3 over 2, plus or minus. Except it's a fraction, so I'm going to put the I right here. All right, these cancel out. And I get x plus 3 halves equals plus or minus square root of 3 over 2 I. And pretty much going to leave it there. We just need to move this over. So final answer, x equals -3 halves plus or minus square root of 3 over 2i. And we're done. All right, I believe 33 was our word problem. So find 2 consecutive positive odd integers whose product is 1,935. All right, so I've gone ahead and put these together. So what we have here is, so x equals the first integer, and x plus 2 is the second integer. They're consecutive but odd. So it's like 1, 3, 5. So you're going to add 2 to that first number. And then when you multiply them together, that's x times x plus 2. So product means multiplication. And so let's go ahead and distribute so that we can simplify this. So just going to distribute the x in there. So this becomes x squared plus 2x equals 1,935. And I know that 1 plus 1 equals 2. 1 times 1 equals 1. So to turn this into a perfect square trinomial on the left, I'm going to add a 1. And you have to do it to both sides. So this guy becomes x plus 1 squared. And this one becomes 1,936. Which I'm hoping is a perfect square. Let's try it out. I'm going to do my prime factorization here. So 1936. 36. 4 goes into 36, and I know 4 is a perfect square, so let's try that. 4 goes into 19. Actually, I wonder if it's bigger than that. Well, we'll get to that. Okay, so 4 goes into 19. 5, 3, 4 times. 16. So 4 goes into 33 8 times, and 4 goes into 6. So there's a lot of 16s. I bet 16 is one. Okay, so I know 4 goes into this again. So yeah, 16 is going to be one of my perfect squares. So that's 1, 4 goes into 8 2 times, 121. And 121 is 11 times 11. So 4 times 4 is 16. 11 times 11 is 121. So I've got two perfect squares here. And I'm going to use the 4 and the 11. Okay, so let's go back over here. So if this can be written as 4 squared times 11 squared, I'm going to keep it like that. So the square root of x plus 1 squared equals the square root of 4 squared times 11 squared. This cancels out. This cancels out. And so we end up with x plus 1 equals plus or minus 4 times 11, which is 44. So now I subtract my 1 from both sides. And I end up with x equals negative 1 plus or minus 44. This I can definitely solve, which is good. We need to find our two consecutive numbers. So let's see here. So x equals negative 1 plus 44. That gives me my 43. And x equals negative 1 minus 44. That's going to give me a negative 45. So I can't use that because they needed positive odd integers. And they have to be consecutive. So we're going to use the 43. So this means that x equals 43. So x plus 2 equals 43 plus 2, which gives me 45. So there are my two consecutive integers, 43 and 45. And that does it. That's the homework walkthrough. And so that should give you all of the practice that you need for this section. Hopefully you were able to do a lot of that on your own, but you can follow this to kind of figure out what you missed. All right, thanks guys.